Hi, you guys. It's Miss Arneson, and I'm going to talk to you right now about surface processes. So, I was looking over what we've covered so far in this class, and I realized that one of the things that I've mentioned indirectly but never really gone over with you guys is the processes on the surface of the Earth that make it the way it is and give it the characteristics that it has. So we're going to talk about those really quick, and this will look at how do natural processes shape the surface of the Earth. We talked about how tectonic plates can shape the surface of the Earth, and the movement of the lithosphere on the asthenosphere. But let's talk about what actually happens like on top of these rock layers that are tectonic plates. So I wanted to look at some tectonic processes versus surface processes by checking out these two mountain ranges. So this is, of course, our mountains, the Organ Mountains, and you can see how jagged and rough they are at the top. So these have really fine pointed edges at the top, whereas if we look at the Appalachian Mountains, I think this picture is in Tennessee, so it's basically on the other side of the country, you can see that their mountains are much more worn down. They're not sticking out so far. And that's because they've had a lot more surface processes happen to them because they're a lot older than the Organ Mountains are. So let's go ahead and look at this a little more closely. Um, First, I wanted to mention some artificial processes that can shape the surface of the earth. So humans, of course, we will bulldoze things, we will pave over them, we will make tunnels and stuff. And those are all changes, of course, to the physical environment, but those are done artificially. So we would not consider them natural, but because we're doing them, they are artificial. So this is one of my favorite examples of an artificial process that is shaped landmarks on this planet. So here is where ground zero was for the nuclear test that took place at the Trinity site in New Mexico during the Manhattan Project before World War II ended. And where they detonated the bomb, there's actually a new type of rock that formed underneath where the blast was. It's called trinitite. This is how you spell it if you want to look it up. You can buy pieces of it. You should not, if you ever go to the Trinity site, take any of these pieces because that would be illegal. I had a student when I was at Camino that gave me a little piece of trinitite, and it's still radioactive. So if we had a Geiger counter, we could like measure it, and it would be all it would be like, no, this is radioactive. But it's not like unsafely radioactive to where you can't have a little bit of exposure by holding it in your hand for a second. So anyways, that was an artificial process that shaped the surface of the earth. And this is kind of a cool astrobiology note, but when we're looking for other organisms, other intelligent life forms on other planets, one of the things we're looking for is artificial processes. So evidence of things that are not natural in the environment that have to have been made by some sort of intelligent creature. And so that's kind of fun. I enjoy astrobiology, which is a real field of science, ladies and gentlemen, looking for aliens. Okay, so let's get down to the nitty gritty of this. What are these mechanisms that do it? So the first one is weathering, and you definitely want to write this down. The definition of weathering is like breaking apart of a rock. Okay, so when we take a bigger rock, and the reason we're talking about rocks here and breaking them down is because we're describing the lithosphere here. So remember, the lithosphere is going to be all of those plate tectonics that we live on. And so even if you're at the bottom of the ocean, if you are at the top of a mountain, you're still talking about these processes happening to rocks, breaking them down into smaller pieces. And then eventually those smaller pieces or the rocks themselves get pulled back into the rock cycle and they get melted, and then you can have new rocks form in volcanoes or other processes. So some examples of that, if you've ever been to Arches in Arizona, I think it is. I don't know because I haven't ever traveled there, but I think it's in Arizona and you can look it up. It's like Arches National Park. There is a bunch of rocks in these arch shapes where you can like go walk under one and be like, hey. And they have been weathered into this shape. So little pieces have been broken down over time from this original rock, which was completely solid. Here's another one that's one of my favorites. So this is what happens when a little bit of ice gets into a crack or something. So you get water in there, and then when it freezes, you have the liquid expand, right, when it freezes into a solid. And so you can actually like break apart a huge chunk of rock by putting some water in it and then freezing it. There's also some other examples. Those ones that I mentioned right now are physical processes. So, like if you have sand blasting onto this other sandstone here, then it's going to break off little chunks of it. If you have ice, that's physically just going to rip apart the rock. But when we're talking about chemical processes, sometimes those are less obvious. There's two that I put on here, but there's even more. I'm going to sneeze, hold on. So bleaching, if you live in the desert, you know about bleaching. Anything you put out in the sun will slowly break those chemicals down and change the color of them. So when you find bones, a lot of times in other parts of the world, they're not going to look so nice and white as if you find them in the desert, and that's because of this bleaching process. This is a statue, I believe, from Germany, and this was a big deal a couple of decades ago. It's not such a big deal now, but something called acid rain started showing up. And acid rain is literally when the water would become more acidic than normal. So naturally, normal water is slightly acidic, and so it will break things down. But when a lot of pollution was in the air because there weren't very many regulations, they would have acid rain that would literally melt statues and basically like burn the leaves off of trees. So you'd have an acid rain event, and then a few weeks later, you would have no leaves left on the trees. And so that was a really big deal, but a whole bunch of regulations were made. And so now acid rain is way less common, but it is something that would occur naturally, just not as bad as it does when humans are artificially polluting the atmosphere. And you can see, I mean, if something melts rocks, then it's pretty intense. So that's another chemical example of weathering. Okay, so the next part of this process is erosion. So when we have weathering, afterwards you're going to have erosion. So weathering is breaking down the bigger chunks into smaller chunks. It could be a big chunk of bone, it could be a big rock. You break it down into smaller pieces by wind and rain and rocks falling on other rocks. That's considered weathering. Erosion is when those broken down materials move from one location to another. So that's really what you want to write down as the definition of this. Erosion is when the broken down materials move from one location to another. So I just put a New Mexican arroyo here because we know that that's basically what happens in an arroyo. You get all of this fine sand at the bottom, and as the water comes through during rainy seasons, it moves all of this sand that is making up the walls of the arroyo way further down and moves that sand. This is an example that I don't think there's really an example of in New Mexico anymore. We used to have our mighty Rio Grande had some meandering, but now we've channeled it all off and we don't let it go where it wants naturally. So this is called a meandering river, and what that means is that it's going through a relatively soft part of the crust, and so over time, as the little pieces on the sides of the riverbank get moved, the river changes shape. And so you can see all of these different pieces. Like here, this is called an oxbow lake. And it's basically like this river used to come over here, but over time that straightened off, and now it just goes straight from here to here. And it left this little piece of a lake, which, well, it's now a lake, but it used to be a piece of a river. And so this happens, and you can see how it moves a lot over time. So you can see all of these bands here of different colors. Those are all where different parts of the river was. And there's a smaller little meandering stream over here. It's so cute, okay, compared to this big river. But that's one example of erosion. We're moving some of the sand, some of the little rock particles, from one part of the river downriver, and when we do that, we are having erosion. The last part of this process, so you have to break it down with weathering, then you move it with erosion, and then you leave it somewhere, and that's called deposition. And so this is an example of deposition. So this is right here we have some valleys in this mountainous area where you can see that water has been coming down. The way we can tell that water has been coming down here is we can see like this fan, it's called an alluvial fan. And all of this is going to be like this finer sand than what's surrounding it over here. And that's because it gets left there, it gets deposited. So deposition is the last part of this process. It's where the broken down materials get moved or get left somewhere different than when they started. So moving them is erosion, breaking them down is weathering, leaving them somewhere else is deposition. And I don't know why they want you to know the difference between those three, but a lot of times they do. So you got to make sure to write them down. Okay, one of the things I wanted to really know is the reason this happens on our planet is because we have an atmosphere and we have water on our planet. There are some places that have an atmosphere but do not have water on the surface of them, like Mars. I'm going to show you a picture in a second. Mars looks like it at one point had liquid water on the surface, but now it doesn't anymore. So we can see atmospheric weathering happen, but we don't really see water-based weathering happening anytime now on Mars. All that is there is left over from probably millions of years ago. We think Mars at one point did have a thicker atmosphere and it did have liquid water on the surface, but now all the water that we can find is either frozen if it's on the surface, or if it's underneath, it's like underground water. And so then it's not doing any surface processes that we could see. Could there be life under there? I don't know. It would be exciting to find it, right? So just know that this cushion of air that's around our planet and the water that's moving in and out of that, those are the major causes for weathering and erosion and the major ways that things get moved around. So here is an example from Mars, and it looks very similar to that alluvial fan picture that we looked at for Earth. So this would be the deposition area where all of the sediments have been left, the alluvial fan. And then here we would expect that water has come down through these valleys right here. And so we can use Earth to actually study Mars by seeing what processes are happening on the Earth and then looking at Mars to see how they might be similar or different. Although on Mars you can still see some more craters, you can't really see those on Earth, even though we do have all the time, there are little bits of space falling into our planet. We do have that. We just don't have the evidence of it anymore because it gets washed away by weathering, erosion, and deposition. The moon, of course, doesn't really have any water or an atmosphere. It does have like kind of like a really thin, like, puny atmosphere that doesn't really count for us. And then, of course, there's no water on the moon. So all of those things that have whacked on its surface over time, and you guys really picked up on this in one of the first activities for this unit, that the weathering on the moon doesn't happen. There really isn't any deposition occurring where the sediments have been moved through erosion. And so it's much different than our planet here. All right, guys, I hope that that's a little bit clear for you.